Hello, this is paper 1 of the 2019 TMUA, so 20 questions. Kicking off with question 1. F of x quadratic in x, it passes through those 2 points, it's got a turning point at the second one. Okay, find the expression for f of x. So let's say then that f of x, let's put a general form, x squared plus bx plus c. So when x is 1, we're getting minus 1, so minus 1 is a plus b plus c. When x is minus 1, we're getting 3. So a minus b plus c. So that means then that b must be minus 2. Then we got this turning point here. So 2ax plus b equals 0 when x is minus 1. So that means that 2a is equal to b. So a is minus 1. And that's already looking like it's going to be A, and C will be, 2. So A. Right, nice starter. Question 2, find a complete set of values of the real constant K for which that expression is positive for all real values of X. So that's a positive quadratic, so we want no roots. So we want the B squared minus 4AC to be less than 0. So what is B? It's K plus 2. I want to square that. Minus 4a is 1, and then c is 1 minus 2k. We want that less than 0. K squared plus 4k plus 4 minus 4 plus 8k less than 0. Get rid of those. K plus 12 less than 0. Positive quadratic, so it's between the roots between minus 12 and 0. Another A. Question 3. Find the coefficient of x in this expression. 1 plus x to the 0, 1 plus x to the 1, 1 plus x to the 2. Right, okay. Well, when we expand these, I mean, we know from Pascal's triangle that the x term is this diagonal here, which is just the power of the bracket. So we're just going up and counting numbers. So we're summing up 0 to 80. So that's 81 times 40, which is 3240, which is E. Well, that was a really quick one. Sequence xn also shows the value because it comes up a lot of being able to work out triangular numbers quickly, which is what we're doing by adding up 1 to 80. So sequence xn is given by x1 is 10, xn plus 1, and we're square rooting each time. So what is the value of x subscript 100? So we're going to do 99 square roots on this. So that's going to be 2 to the minus 99. Yeah, so C. Yeah, because let's just double check. So we go half, a quarter, an eighth, etc. So that's 1, well, that's 2 to the minus 1, 2 to the minus 2, 2 to the minus 3. Yeah, we just go on, we do that 99 times. So yeah, that's fine. So 5. S is a geometric sequence. The sum of the first 6 terms is 9 times the sum of the first 3 terms. So a 1 minus r to the 6 over 1 minus r is 9 times a 1 minus r cubed over 1 minus r. Get rid of that, get rid of that, and that, and that, and that. And then we've got the 7th term, so that's ar to the 6 is 360. So what's this giving? R to the 6 minus 9r cubed plus 8 is 0. So quadratic in r cubed. So r cubed is going to be, so 1 or 8, isn't it? It's on this, 1 or 8. Can't have 1 because that will mess up that. So we'll have to have that r is 2. So a is going to be 360 over 64, which is what, 45 over 8. That's right, isn't it? 4 90s. So yeah, 845, 45 over 8. Coolio. Question 6. Circles with those equations have exactly 1 point in common. Right, oh, we got a unknown radius here. Find the difference between the 2 possible values of r. So we've got a fixed circle. We've got a circle somewhere else, which could be just touching there, or it could be the center's fixed. So it would be doing something like that. So it's either touching on the outside or the inside. depending which way round. So we've got a radius of that. Well, we've got a radius of that on the first one, or we've got a radius of all of that. So the difference is the diameter of the other circle. So it was 2 lots of 8, 16. That was a nice question, just having to think it through. 7, a curve has equation of that. The gradient of the curve at x is -1 is a function of q. Yes, it would be. Find the value of q which minimizes that. So we're going to have to differentiate with respect to x, put -1 in, and then differentiate with respect to q. So y dash is going to be -2x, 2qx plus 3, just doing product rule, plus 2q minus x squared times 2q. Stick in a -1 for x. So minus 1, y dash for -1, so that's going to be 2, 3 minus 2q plus 2q minus 1 times 2q. Now I need to differentiate that one with respect to q. So that's going to give what, -4, then another -2, do the easy bits, and then I've got a 4q squared, so plus an 8q. I want that to be 0, so q is going to be 6/8, 3/4 f. Yes. Question 8. The function f is such that it's between 0 and 1, for x is between 0 and 1. Trapezium rule with n equal intervals is used to estimate, produces underestimate using the same number of equal intervals. Which of the following produces an overestimate? Right, okay, so we've got an underestimate, so we've got something which looks maybe along the lines of that. So when we do trapeziums, we're going under the curve because it's curving away from that straight line. So we want to get an overestimate. So not that one because it's just moving everything up, and not that one because it's just stretching it upwards. This one is moving it to the left, but it's also moving the integration window to the left, so that's the same. This is going to be reflecting it in the y-axis, and then, it's doing exactly the same thing, so it's just going to be integrating that, so it must be this. Yeah, so this has flipped it over, so it's gone from looking like that to looking like that, and then it's shifted it up. So yeah, I mean, another way of looking at those, this reminds me of I've seen a question similar to this before, where you can also think of this bottom one, E, so you could think of it as 2 transformations, or it's like saying, rather than doing our trapeziums from the x-axis and then underestimating everything, we're actually starting at the line 1, and which is fine because f of x is between 0 and 1, and then taking our trapeziums going down because we're doing 1 minus whatever the f of x value is. So we're going down here. So it's a difference between 0 plus the f of x value, which is going up from the x-axis, and then a 1 minus it, which is coming down from 1. So you're flipping then from having an underestimate to an overestimate. So yeah, definitely E, although it helps to have seen a similar question like that before. Question 9. P is a positive constant. Find the area enclosed between these curves. So we've got y is p root x, so something that looks like that, and x is p root y, so something that looks like that. So we need this point of intersection because this is just a quadratic, isn't it? So intersect then. So p root x is x squared over p squared. So p cubed is going to be x to the 3 over 2, so x is p squared. So that's the intersection point. Now I'm going to want to integrate, so which way round? I want to go from 0 to p squared. The big one is this, so I need to do the p root x dx first, and then take off the other one, which is the x squared over p squared dx. So that is going to be so I'm going to have, let's do it as a p. This is going to be 2/3 p to the 3 over 2, 0 p squared. And then I'm going to have a p, I've put it inside the bracket now. So a third, 1 over 3 p squared of x cubed, 0 to p squared. So that's going to be 2/3 of p to the 4, This, well, we don't have to worry about the zeros on either of these. Oh, I've put a p at 3 over 2. I should have meant x there. I was already starting to put that in and realised it'd be too many steps. This is going to be p to the 6 divided by p squared. So again, p to the 4 and a third p to the 4. So I'm going to get a third of p to the 4. D. It's a fairly standard integration question, that one. Evaluate this. Oh, an integral with a mod in it. So, well, the mod only matters when we've got negative x. So let's go from -1 to 0 of minus x1 minus x dx, and then add on the integral from 0 to 3 of x1 minus x dx. So that's all we want on this. So that is going to be a minus x squared over 2, and then an x cubed over 3 from -1 to 0. And then we'll have an x squared over 2 and a minus x cubed over 3. So we're just flipping around some signs on some of those. So we got nothing, and then stick this again. So we're going to have a plus a half on that, and then that'd be minus a third will become plus a third. That's dealt with that one. And then the zeros we don't have to worry about when we get to the end. So we're going to have a plus 9 over 2 and a minus 9. So what's that all in all? That's going to be -4.5 plus a half, so -4 plus a third, so -3 2/3, which I've done in proper fractions. That's what F. Okay, who wants to do improper fractions? Find the sum of the real values of x that satisfy these simultaneous equations. Right, so first one is telling us that xy squared is equal to 3. So I'm going to get the sum of x values. But it's sort of pushing me to sub in and find y, isn't it? So yeah, I think I will. I don't really fancy subbing in here. I don't know. Let's stick with it. Stick with the easier way. So I've got a log base 3 of x is log base 3 of 3 over y squared, which is log base 3 of 3 minus log base 3 of y squared, which is 1 minus 2 log base 3 of y. And I need to multiply that by log base 3 of y. So I've got a log base 3 of y minus 2 log base 3 of y squared is equal to -3. So that's a 2z squared minus z minus 3 is 0. So that's going to be 2z, z. You're going to want to have a -3 and a +1. So we've got that. I've used up too much of the screen here. Log base 3 of y is equal to 3 over 2 or -1. So y is equal to 3 to the 3 over 2 or a third. X will be equal to, so we want to square y, which you get 27. 3 over 27 is a ninth. Or we're going to square it and get a ninth, multiply 9 by 3 and get 27. So 27 and a ninth, which is not one of those 7 answers. Do we have an, oh, we got an eighth answer. Excellent. So H. That would have been worrying otherwise. Question 12 is given that dv dt is that v is 7 when t is 1. Find the value of v when t is 9. Right, well, we don't want that on the denominator, so let's rationalize. So I'll get 24 pi t minus 1, 1 minus root t, and then that's going to give me a 1 minus t on the bottom. So cancel that and that and put a minus sign there. So I've now got that dv dt is 24 pi times root t minus 1. So I can just integrate this thing then. So v is going to be 24 pi and then the integral of that. So that's going to be 2/3 of t to the 3 over 2 minus t plus c. So that's 7 when t is 1. So 7 is 24 pi times minus a third plus c. So c is going to be 7 plus 8 pi. And now I need t is 9. So v is going to be 24 pi, then 2/3 of 27, so that's 18. Get rid of that, just put 18, minus 9, plus c. So 9 times, so that's 216 pi, plus 7, plus 8 pi. 224 pi plus 7, c. Oof, right, that was a lot of work. Question 13, find the maximum value of that. So that's 2 to the sine x squared minus 4 lots of 2 to the sine x plus 17 over 4. So I've got a positive quadratic. So great. But we got limited. We do have limited domain on this, don't we? Because the sine x is only going between -1 and 1. So we've got a positive quadratic which is being chopped at the end. So we need to look at the end values, and whichever one comes out the highest is going to be the maximum value. So if I put -1 in, I'm going to get a quarter, well, -1 for sine x, a quarter minus 4 over 2 plus 17 over 4. So that is 18 over 4 minus 8 over 4, 10 over 4, which is 5 over 2, which is one of the answers. If I put 1 in, I'm going to have 4 minus 8 plus 17 over 4. Well, that's going to be smaller, isn't it? If I take 4 off of that, I'm just going to have a quarter all in all. So it's going to be 5 over 2. Another really nice question. They've had some nice efforts so far in this. Anyway, let's not get distracted. Question 14. X satisfies the simultaneous equations that and that. X is between 0 and 360 degrees. Find the sum of the possible values of x. Right. So, well, if we solve for, how am I going to do this? I think, yeah, let's do the obvious start, I suppose. Multiply that by √3 all the way through. Then I can subtract the bottom one from the top one, and so I've got 4 cos 2x is minus 2√3. So cos 2x is going to be minus √3 over 2. So what does that mean then? 2x is going to be, thinking about the cos graph, that'll be what, 150 degrees or 210 degrees. So either side of its minimum that it's got at 180 degrees. So that gives that. So x is going to be, well, 75 or 105, but then you can add on 180 to these because we're doing it in 2 x's. So 255, sorry, for 180, and then 285. But these won't necessarily work, all of them, because, yeah, they might not go back into these equations when we take into account the sine ones. So if I go back into the top one, so if I had sine 2x, so I'll be saying sine 150 plus √3 cos 150. So that is going to be a half minus 1.5. So that does equal -1. So that's fine. And then I'm going to have at the bottom one √3 sine 150 minus cos 150. So that is going to be a √3 over 2 minus √3, yeah, minus √3 over 2. So yeah, √3 over 2 minus √3 over 2 is √3. So that works. So these ones are fine. But will the other ones be fine? If I do that again for 2 10s, I'm going to end up getting a -0.5 minus 3 over 2. So that gives -2. So that doesn't work straight away for that first one if I put 210 degrees in there. So it's just going to be these ones, which add up to 330, the 75 and the 255. All right, yeah. Yeah, they're sneaky sometimes, those simultaneous trig functions. Find the real non-zero solution to all of that. Wow, okay. Well, let's get it all as powers of 2, I think. So I've got 2 to the 9 to the x, and then I've got 2 cubed to the 3 to the x. Yeah, that's what I'm doing, isn't it? So that's going to be 3 times 3 to the x. So that's going to be 3 to the x plus 1. So that's 2 to the 3x plus 1. And then, but I got 1 over that. So I'm going to be multiplying that by 2 to the minus 3 to the x plus 1. So that's going to be 2 to the 9x minus 3 to the x plus 1. And that equals a quarter. So the 9x minus 3 to the x plus 1 must equal minus 2. So that's obviously 3 to the 2x. 3 to the 2x minus, well, 3 lots of 3 to the x plus 2 is equal to 0. Right, so at least we got a firm footing on this. So that's going to be a minus 2 and a minus 1. So 2 or 1 is what we're saying 3 to the x is. 3 to the x is 2 or 1. So now we've got to do to find a real non-zero solution. Right, so we don't want that one. We want to have the log of, well, log base 3 of these. Log base 3 of 2 is going to be equal to x, so a. Right. That was a fiddlier one than normal for the log ones. Normally the log ones are super quick, but that was not quite super quick. Given that that thing plus that thing is 14 and that thing is 6, find the value of that. Right, so this is moving it to the left, so that is going to be equal to the 1 to 2 integral is 6. So that bit's going to be 30 when we do 5 6s. So this bit must be minus 8. So I got a minus 8 plus 6, which is minus 2. Wow, that was a gimme question, that one. Oh, okay. But, you know, they don't always have to have all the difficult ones towards the end. Find the fraction of the interval 0 to pi for which that inequality holds. Right, so we either need them both to be negative or both to be positive. So if we were going to have, well, let's go for the positive ones first of all. So we want sine theta to be greater than or equal to cos theta. So that is going to happen. Yeah, we've got that, and we've got where am I going? That, but oh, we're only going up to here though, so we don't have to care about that bit. So it's going to be everything after pi by 4. So pi over 4 to pi for that one. And then we need sine 2 theta to be greater than or equal to a half. So that's going to be between pi over sine 2 theta. So pi over 6 for 2 theta. So pi over 12 up to 5 pi over 12, because we're halving, as in pi over 6 to 5 pi over 6, and then halve them both. So, right, so that gives us that first block then, which is going between 3 pi over 12 to 5 pi over 12. So that's a start. And then if they were both going to be negative on these, well, the first one's going to be easy because that's going to be 0 to pi over 4. And that's going to be what we just had. And then for the other one is going to be outside of those ranges, so 0 to pi over 12, or the other side, which doesn't fit. So it's just going to be that bit. So we've got a 12th and 2 12ths. So we've got 3 12ths, we've got a quarter, which is C. That was a nice question. Find the shortest distance between that curve and that line. So we've got a positive, well, we've got a quadratic that's looking like that, and we've got a straight line that's looking sort of like that. We want to get this shortest distance between the two of them. Right, but that shortest distance is going to occur, we want to get points See, when they're parallel, because all the way up until they're parallel, the straight line is catching up with the parabola, but then past the parallel point, the parabola is moving away again. So we need to find where the gradients are the same. So that's going to happen when x is equal to 1, when the gradients are the same. That's when they're parallel to each other. So what does that mean? So we need to find the distance then. When x is 1, we need to find a distance between this point, which is going to be, well, when x is 1, y is 5. But then how do I get what that point is? It's going to be an intersection perpendicular to this. So I'm going to have an equation which would be y minus 5 is minus a half x minus 1. That's the straight line perpendicular to that other straight line, which passes through 1, 5. And that has to then intersect with this thing. And that gives me the other point that I need to get the distance to. Yeah, that works, doesn't it? So I've got that minus x over 2 plus a half plus 5 is equal to 2x minus 2. So 7.5 is 5 over 2x, mixing my fractions here. So x is 3 on that. So when x is 3, we're getting that y is 4. So I need the distance between 1, 5 and 3, 4. I think is what I want, isn't it? So that's fine. So that's going to be 2 squared plus 1 squared rooted. So root 5. B. That was a lovely question, that was. Really nice. Find the value of that. Eesh. Right, well, let's look at each one of them. Let's start writing out the series that we've got here. So we've got a sine 10 plus sine 100 plus sine 190 plus sine, what have I then got? 280. Okay, so what's that telling me? Sine 370. Oh, we've looped. Right, so we've gone back to there. That's the same. So what do I get from one of these blocks then? Sine 10, sine 100. Let's draw out the graph. Yeah. So we get that sine 10 around about there. Sine 100 is there. Sine 190 is there. Sine 280 is there. All right, so they cancel out. They're the same and they're the same. So they're all 0. And we can do that. But we've got 91 of these and they're in blocks of 4. So we can get rid of the first 88. It'll leave us with 3 blocks. 3 left, I mean, after the blocks. So we're going to have the first 3. These two cancel out, sine 10 and sine 190. So we're left with sine of 100. So C. That's another really nice question. And that brings us to the last one. What is the complete range of values of k for which the curves with those equations intersect at 3 distinct points, of which exactly 2 have positive x coordinates? Yeah, okay, well, they've given us a fixed graph here, so might as well put that in. So we've got, so this is an x squared minus 12, so that's going to be x plus root 12, x minus root 12. So we've got a positive cubic that's doing that. That's minus root 12. That's plus root 12. And we've now got a negative parabola, negative quadratic. This has got to intersect at 3 distinct points, of which exactly 2 have positive coordinates. 3 distinct points. So where's this? So we've got a negative parabola. So it's always going to intersect somewhere down here because that's going to drop off quicker than the parabola. And then it's got to intersect twice over on this side. So we need to have something that's doing, I don't know, something like this. So what does that mean? Complete range of values of k for which the curves with equations. So what's the limiting factor on this? So we have to have 2 positive x coordinates. So we can't go above here. That's one limiting position of how far up we can move that parabola. as in they're going to intersect. So if this goes through the origin, then that's necessarily going to give us one of the answers we want, isn't it? So we'd have 0 is equal to k minus 2 squared. So 0 is k minus 4. So if k is 4, then we're okay. Well, no, if k is 4, we're not okay because it needs to be positive. So k's got to be less than 4. So it's looking like B or E, potentially anyway. So, well, we'll see what happens with the other ones. So what's the other limiting factor? So we need to have 3 distinct points. Well, I suppose it could be so low it doesn't intersect on the other side. So it depends where this is. What's going on with that? Let's find that minimum point, because it'd be nice if they just touched, as in the maximum and the minimum meet each other. Otherwise we could get into right big mess on this. So 3x squared minus 12, that's the differentiating the cubic. So if that is going to be a turning point, we're going to have that x is going to be plus or minus 2. So yes, and that is the maximum of this. So we've got, this is at an x coordinate of 2. So that's going to be the other limiting factor when we've got this thing just touching. So what's the y coordinate of this then? So when x is 2, we've got 8 minus 24. So we've got minus 16 when x is 2. So y minus 16 is k. Oh, just that's equal to k, because yeah, of course that thing's going to be 0, isn't it? So k's got to be greater than minus 16, and it's got to be less than 4. So E. Yeah, another really nice question to end on. There's some beauties at the end there. That question 20 was great. I like 19. That was really good. So was 18. So was 17. I mean, these are all just brilliant questions. 16 was a bit of a gimme, but it was still quite nice. So yeah, they had 5 absolute crackers at the end there. Plus they had some other nice ones, like I didn't like that one very much, 14. That was quite fiddly. That was nice, 13. I like the one with a circle. 12 was just boring. So was 11. Yeah, that was fine. 10. The one with a circle was really good. 9 was standard. Was it? Where's I think the circle one? Oh, is it really that early on? It was question 6. So yeah, 6 was nice. But yeah, the last sort of half dozen or so questions on this were really, really nice. So yeah, there was, I do enjoy the paper ones at the TMUAs, and that one was no exception. So back with paper 2 fairly soon.